So I did my biology project on paleontology, and paleontology is a very young science relative to some others, and now it's a very mainstream science. You can think Jurassic Park, or it's taught in school, everyone knows about it, but at its very beginning, it was an obscure and controversial science, despised by many intellectuals and many religious institutions because it knocked man out of his special place in the universe. And it didn't actually begin, like I said, it's very young, until the 18th and 19th centuries with Jorge Cuvier. And he was the first person to actually champion the idea of extinction. And extinction sounds normal to us, but it's a very strange concept when you think about it. The idea that an entire species could disappear off the face of the earth, especially when they didn't actually know how old the earth was, and the best guess was about 6,000 years old. Now, fossils had been discovered by ancient people, but they didn't know what they were, and that might have spawned a lot of the legends and myths that we know about cyclopses or anything like that. But Jorge Cuvier was the first person when there was an extinct mastodon fossil found in New England. He analyzed it, compared it to extant elephants in Africa and India, and actually pronounced that it was extinct. And his theory was proven correct when Lewis and Clark, on their expedition through the Louisiana Purchase, found no evidence of extant mastodons living in the Americas. However, it was his rival, Charles Lyell, that proposed gradual extinction, which would work more concurrently with evolution and is what we think of now today when we think of extinction and evolution. And the difference is that extinction on its own, it was thought that, large scale cataclysmic events would cause extinction, especially not knowing the age of the earth. And the most recent cataclysmic event that would cause an extinction was thought to be Noah's flood, and Charles Lyell disagreed. And this brings us to evolution. So evolution works with paleontology to explain observations and explain predictions. For example, they were able to work together to narrow down the age of humans. It was once thought that humans were as old as the Earth itself, and it's not an unreasonable guess with no evidence to the contrary. However, using the fossil record and molecular biology, they were able to narrow down our age to about 3.4 million years, or 700,000, or 40,000, depending on how you define it. However, in its early days, evolution was not an accurate model. Charles Darwin proposed that species would be this complex or that complex in these layers, and it was incorrect. The lower layers were far more complex than they should have been when paleontologists actually examined them. So, by the late 1800s, a lot of scientists regarded it as untrue. Scientists opted instead for orthogenic models to explain their observations. And orthogenesis is the idea that all species tend toward certain trends in their evolution. For example, the idea that all species will eventually increase in biological complexity due to some driving force that was never defined. However, evolution was revived in the 1920s when radiometric dating increased the estimated age of the Earth by 20 times. And after this, Darwin's model made a lot more sense and it became a lot more accurate. All the fossils they were finding, and they were way too complex in the lower layers, now they made sense. All these strange time gaps that they couldn't explain with the old age of the Earth, now they made sense. And now, most importantly, scientists could predict instead of just observing and describing. For example, in Ellesmere Island in Canada, which is now a tundra, as you can see here, they dug up fossils and they found a massive marsh. In ancient times, it used to be a marsh, and they realized that this would have been the perfect lair and the perfect place to find a half water, half land fish, something that was amphibious in the transition between animals living in the water and living on land. And they did find it. They predicted they would, and they found the species called Tiktaalik, which is a very strange looking fish because it can swim in the water and walk on land. So that leads us to the present day application of paleontology. And now, and since the 1920s, with the takeoff of the automobile industry, paleontologists are hired by oil companies to find new reservoirs. And by examining the fossils in a given layer, which they find these layers by drilling boreholes near rivers or on ocean beds, and by looking at the fossils in that layer, they can tell whether an oil reservoir could potentially exist there, because only certain types of life would later turn into oil reserves. So they can look at that type of fossil. and the science is still being refined today. A 2020 paper revealed a new and more cost effective method of finding the correct parameters for multi stage horizontal wells. And I have no idea what this means. It's very complicated and I do not understand it. However, the idea is just that the science is still being developed to this day and it's useful for humanity as a whole. Speaking of this cutting edge new research, numerous scientific journals publish new discoveries all the time, such as Paleontologica Polonica, which is a free online journal that anyone can access. Their most recent article examines ontogeny and variation in the skull roof and brain casing of a hadrosaurid dinosaur from the Upper Cretaceous period in modern day Montana. And ontogeny means the development of a species over its life. For example, how does a species change between age 5 and age 10? And they found in this hadrosaurid that the subadult skull is approximately 2/3 as wide as the largest adult and lacks a nasofrontal crest, suggesting that the crest formed relatively late in ontogeny compared to some other hadrosaurids. And what this means is that over the species' lifetime or its growth from its teenage to adult years, this crest formed very late in its ontogeny, meaning it doesn't form this until it's much older rather than very early in its life. And hadrosaurids have very unique ontogeny. If you look on these front legs, you can see that when they're kids, they actually walk on 2 legs more. But when they turn to adults, they become quadrupedal and start walking on 4 legs. So it's very interesting. And speaking of these new cutting-edge scientists conducting all this research, Stephen Brusate is the author of Rise and Fall of the Dinosaurs, which is a famous paleontology book which gives lay people a better understanding of the world of paleontology. It breaks things down in very simple terms and makes it easy to understand, and it's gotten a lot of people into paleontology. He has discovered, in addition, more than 12 extinct vertebrate species, which is an astonishing amount. And I believe now he teaches at the University of Edinburgh, although he is from Chicago. And in conclusion, paleontology took a long time to reach its current state of calm. Its tumultuous history developed alongside Darwin's theory of evolution, and they helped each other out. Paleontology is invaluable to the oil industry, helping fuel the modern economy and advance human technology. And cutting-edge research is being conducted all the time by young, prestigious scientists such as Stephen Brusate. And that is my presentation. Citations will be in the description.